Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about eclipses and eclipses of the sun and the moon and why they occur and how we can go about observing them. So let's get started with why do we get eclipses? So why do eclipses occur? Well, in a way, it's a lucky coincidence that the moon and sun are the same apparent size as seen from Earth. So apparent size means how big they appear on the sky. Sun is obviously a lot larger than the moon, but the sun is also a lot further away. And they subtend an angle of about 30 arc minutes, which is about half of a degree. So if we think about that, if you put the moon on the horizon, that would mean that 720 moons could fit around the horizon. That's how small the moon appears in the sky. And the sun appears the same size. Now we can have two different types of eclipses, a solar eclipse and a lunar eclipse. A solar eclipse occurs when the moon passes in front of our sun. A lunar eclipse occurs when the moon passes into Earth's shadow. And we're going to look at both of those in more detail. But start off with, what is the geometry of the eclipse? Well, let's look at specifically the types of shadows that we can get. And here we are looking at the shadow cast by Earth. So this is the sun. Here's the Earth. And then the shadow is cast by it. Now the deepest part of the shadow is called the umbra. And we see that down here. That something in that part of the shadow would be completely invisible. And that's the dark portion of the shadow from the edge of Earth here out in this little cone shape. That would be the darkest part of the shadow. That is where sunlight is completely blocked. No sunlight gets through. The penumbra surrounds this, and that is the region going up this direction in this larger cone, inverted compared to the other. And that is where we would get a partial eclipse. In that case, if something is in the penumbra, you would get only part of the sunlight blocked. So some sunlight is still getting through. So we can look at this and then apply these types of shadows to both lunar and solar eclipses. Let's start off with a solar eclipse. In a total solar eclipse, you get the entire face of the sun is blocked. Now here is the geometry of a solar eclipse. We have the sun, the moon in between, and the Earth here. The moon then casts the shadow on Earth. And because the moon is small, it's a very small shadow and does not cover the entire Earth, but comes almost to a point here. That point would be the area where you would get a total eclipse. That's where you would see the sun completely blocked. And if you're any place else on that, you would either see a partial eclipse or may see no eclipse at all. It's quite possible for an eclipse to occur in one part of the world and not be visible at all in the other. Now let's look at some images of these, a total solar eclipse. Here we see the sun is completely blocked. So we do not see the surface, but we do see the corona, or the atmosphere of the sun around it. The corona is invisible to us. It's there all the time, but we can only see it when the rest of the sun is blocked because it is so much fainter. Now we can look at the eclipse, and there was a famous eclipse that occurred in August of 2017 that went across much of the United States. In fact, went across the US from coast to coast. And here is a little time lapse showing how that occurred. And you can see then that we will start about here, and the moon is covering up the sun. It reaches totality. We see the corona around it, and then it falls away from the sun. And you'll see a partial eclipse. Now, depending on where you were, you may have been able to see this eclipse more or less, depending on what part of the country you were in. It was only a narrow band that is able to see the total eclipse. You've got to be positioned just right. If not, most of the United States saw a partial eclipse, which would be something like this. Only part of the sun's face is blocked. Now we saw it go through that stage during that total eclipse animation. However, this might have been the maximum amount of eclipse you were able to see, depending on your specific location and how close you were to that path of totality. Now, another type of eclipse is what is called an annular eclipse. Annular is for annulus or ring and not for annual. So we're not talking about an eclipse that occurs every year. We're talking about an eclipse where there is a ring of material left around. And this is actually the part of the solar surface. So we're still seeing a ring of sunlight around the moon. How does this occur? Well, this occurs when the moon is more distant, when the moon is further away from Earth. So it appears smaller than the sun in the sky and therefore cannot completely block it out. Now let's look again at the geometry here. Come back to that a little bit, depending on where you are in this location. If you are in the umbra, then you would see, so if you're located in the umbra here, any place in point 1, you would see a total eclipse, the moon completely blocking out the sun. If you're in part 2, you would see, or part 3, you would see part of the sun blocked. So that would be something like this, where only a portion of the sun is blocked. 2 being a little bit closer to the umbra, you have a larger percentage blocked as compared to 3 closer to the edge of the complete edge of the shadow, only a small amount is blocked. And then position 4 here would give us the annular eclipse. At that point, the totality would end right here. And you would see then the ring of material. And the further you are out here, the bigger that ring would be. Now we also want to look at lunar eclipses. So let's take a look at those. And here again is the geometry. A lunar eclipse occurs. We can have a total lunar eclipse, a partial, or a penumbral again. And again, that depends on where the moon passes through Earth's shadow. So the geometry is a little different. In this case, in the solar eclipse, the moon was between Earth and sun. In a lunar eclipse, the Earth is between the moon and the sun. It is the Earth's shadow that is casting on the moon. Now let's look at these different types. Here example is a total lunar eclipse where the entire moon is in the umbra. And we will see not that it disappears, that it turns a very deep red color the further into the umbra it is. So here's well into the umbra, here's just making it in. And that is because sunlight sneaks into the shadow through Earth's atmosphere. Earth's atmosphere bends light into the shadow, and therefore we don't get a completely dark shadow as we would if the Earth had no atmosphere. The red light is scattered better, so the moon will appear a deep blood red during a total lunar eclipse. During a partial lunar eclipse, you see just a portion of the moon blocked, and you will see that stage as you're looking at a total lunar eclipse, but it'll never get completely covered. You will never get that blood red color. And then you can have a penumbral lunar eclipse, which really isn't all that amazing to see. If you look at the slight difference here, this is showing the line here is the inner edge of the penumbra, or the outer edge of the umbra. That would be complete shadow, and the moon doesn't quite make it into that. However, you're further into the penumbra and a lot of the light is blocked as you get close to the umbra. So by comparison, this is the moon when it is not within the shadow. So the areas here look like hardly any difference, and you get a very little dimming of one portion near the Earth's umbra, but not enough to completely block it out at all. Now, how can we go about predicting an eclipse? We don't get an eclipse every month, even though we get a new moon, which is when a solar eclipse occurs, or in a full moon when a lunar eclipse occurs every month. And that's because the moon's orbit is tilted by about 5 degrees. So most of the time, for example, in this region and this region, the sun and moon would pass well above or below each other, and we would never get an eclipse. Remember that they are only about a half a degree in size. So you can fit very many of them in that 5-degree tilt. It doesn't take much of a tilt to separate the two. There are 2 eclipse seasons each year, which are the nodes. There's an ascending node and a descending node. And when an eclipse occurs, so when a full moon or a new moon occurs near a node, then you will get an eclipse. Then the sun and moon are close enough together. So if you're not near the node, you're not going to get an eclipse. Eclipses are predictable, and we've known about this for a long time. We have what is called the Saros cycle, which is 11 years, 18 years, 11 days and 8 hours long. And at that point, an eclipse will recur. We'll get essentially the same orientation and we'll get a new eclipse. So here we see a number of eclipses starting in the Middle Ages and working their way forward. And we can see how this similar eclipse occurs every 54 years or so. So they change slightly, and you notice that they are moving slightly, but not a whole lot, that we will get almost that exact same eclipse 54 years later. Now, again, over time, they slowly change. So we don't get the exact eclipse all the time. But you can see when these eclipses will be visible. Now, this isn't all eclipses. This is just one specific Saros cycle that we are looking at. But every 54 years, you will get a similar eclipse from that location. Now, how do you go about observing an eclipse? Well, lunar eclipse, very easy. You don't need anything. You can just go look at it. A solar eclipse, you do not want to look at. It is never safe to look at the surface of the sun, whether it's eclipsed or not. It is extremely bright and can potentially cause damage to your eyes. Things like pinhole cameras or solar filters on a telescope, as shown here, can allow you to be able to see an eclipse safely. So here there's a special filter on the telescope that filters out the vast majority of the light. A pinhole camera uses a pinhole in a piece of cardboard to make a mini camera and then allows you to see the image quite safely. There's nothing wrong with looking at a picture of the eclipsed image. It is only staring at the sun directly itself. Now, technically, the totally eclipsed sun is perfectly safe to view. But you got to be extremely careful because you don't know when the eclipse is starting and ending. And you don't want to stare at even a small portion of the exposed surface of the sun can cause damage in a relatively short amount of time. So let's go ahead and finish up with our summary and what we've looked at. First of all, we looked at solar eclipses and lunar eclipses. Solar eclipses, the moon passes in front of the sun. A lunar eclipse, the moon passes into Earth's shadow. And we looked at how they do not occur every month, but there are predictable patterns that allow us to predict when eclipses will occur. So that concludes this lecture on eclipses. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.